Hello everyone, I am Mahfuz Alam Tanmoy from Group 5 of 88812 Numerical Technique Laboratory course. Today I am going to present our final Matlab project and demonstrate how it works. Our project focuses on plotting vector fields through several mathematical operations, particularly gradient, curl and divergence, which are fundamental concepts in electromagnetism, fluid dynamics and many engineering applications. At first, start by taking a look at the main interface of our project. As you can see, this is the home page, and from here you can access any of the operation using the corresponding buttons. Let's first explore the curl operation. After clicking the plot curl button, you will notice a new window is popped up, and there are several input fields where we can enter vector field, component, graphing, plot range, and time range. These parameters allow full customization, but for now, let's keep them at their default values. Now, pressing the plot curl button, you will see two 3D plots are appeared. One show the actual vector field and other show the calculated curl of the field. You can observe that as the vector field flows, the curl vector depicts rotational motion at different point in the field. Now, if I press the play button, you will see how the curl evolves dynamically over time, providing a visual understanding of rotation in a time-varying vector field. Now let's return to the home page. Next, let's check the gradient operation. Clicking the plot gradient button brings up similar interface. But instead of vector fields, here we input a scalar field along with the plotting and time ranges. Once again, we will keep default values for our demonstration, and after clicking plot button, we get a 3D visualization of the scalar field and the corresponding gradient field, which shows the direction and rate of maximum increase of scalar fields. Clicking play button will eliminate the gradient field behavior over time, which is especially useful in fields like heat flow, electrostatic, and pressure mapping. Let's head back to the main page. Finally, we explore the divergence operation. Upon clicking on the divergence button, we can input the components of a vector field as before and select the plot ranges. For now, let's keep the default values. Clicking the plot will generate a 3D field plot and a divergence visualization that shows the amount of flux expansion or contraction at different values. You will see that area with positive divergence represents sources and area with negative divergence represents sinks. When we hit play button, the time-based change in the divergence become clearer. This project not only helped us understand the theoretical concept of vector calculus, but also allowed us to visualize them interactively. In our future version, we can plan to improve it by adding support for custom color schemes and field density control, including real-time equation, phrasing, enhancing the user interface for better accessibility.